And we can see that there's a couple of events already being generated. So for example, it says launch package management process in container. Again, that's pretty weird. That doesn't usually happen, right? You install packages when you create the containers, not when it's already running. You can also see that that someone has written some files into a binary directory with other software. Someone's launched a shell in this container, which is privileged. So yeah, I'm getting lots of info from Falco, just looking at the syscalls and letting me know what's going on. Yeah, I'm essentially collecting metrics, so I'm going to have a nice graph of all these different things going on, so I can monitor for that as well. Okay, so that's Falco. As you can see, it's quite simple. There's not much to it. There is a lot more to it when you start to customize everything and write your own rules and detections and customize the dashboards and everything. But again, that really depends on your use case, right? So this has to be a fairly generic tool. So it can be configured to look for relatively generic things. It is really up to you to configure this and make it your own. There's a sizable community around Falco, so it shouldn't be too difficult. But nevertheless, that's Falco. So again, that was quite a quick demo. It does take a little while to spin up though. So let me give you some time to, so you can take a look at this and hopefully run this locally as well. Yeah, after the timer is gonna finish, we're gonna come back and we're gonna continue with the training. So let me put 15 minutes on the clock because it's gonna take like 5 minutes to get set up. I don't want to give too much time so that we're not wasting too much time with this. But again, it's going to take a couple of minutes just to get spun up. So I think 15 minutes is approximately enough. So that's going to be it from my side for a little while. I'll let you explore Falco on your own, and I'll see you in 15 minutes. So good luck. Okay, so that was 15 minutes dedicated to Falco. I hope you had a chance to run the cluster and experiment with Falco a little bit. Again, like the initial rule set is quite wide and it covers a lot of scenarios. And as I said, it's not strictly speaking a cloud native technology. You can use this on any kind of Linux machine where it can detect syscalls. So yeah, I mean, it's an interesting piece of software. If you're thinking defense in depth, if you're thinking, if someone gets past all of our defenses, do we have anything on the monitoring side of things that can detect commands being issued and bad things happening? And the answer is yes, we have Falco and we can deploy Falco. All right, so now let's turn our attention back to cloud and cloud subscriptions. And I will essentially be walking you through some defense methodologies that you can deploy in your own clusters. Okay, so first things first, defense in cloud is vastly and diametrically different from offense. Sorry, just 1 second. My apologies. It's one of the benefits of doing a remote delivery. You don't get to hear me cough. Yeah, sorry. So I was saying defense in cloud, very, very much different from offense. When you're playing for the blue team, you obviously like to limit the amount of responsibilities that you and your team and everyone in your company has to bear on their shoulders. So this is where the sort of shift right concept comes in. Because when you look at these cloud offerings right here, thinking from the low-level offerings such as infrastructure as a service, all towards something like software as a service, those obviously have a lot more responsibility placed on the vendor, on the service provider, rather than the actual user. Simply thinking back to the responsibility model or the shared responsibility matrix, you can very clearly see that the further right you go on this diagram, the better off in certain ways you're going to be, because you will not have to be worried about that many things. I'd like to share a quote that was said actually at Black Hat Asia a couple of years ago during a keynote. And the speaker essentially expressed the fact that whilst offensive problems are purely technical, everything that happens on the defense side of things is actually quite political. And if you break this down, it's just the sad, unfortunate truth of a motivated attacker not really playing by any rules, not keeping to a schedule, not having to explain anything to their superior and why they're doing that particular thing. And essentially, they will be motivated for as long as there's any kind of incentive for them to be attacking you. But when you are playing on the defense side of things, you are responsible either for just yourself, but maybe for a team of people. And you need to be, sometimes you need to be justifying your existence to people who don't really understand what the cyber defense is all about. And it can be a daunting task to plead your case saying, look, when we are operating at our finest, you will never know we're even here and there will be no security breaches, right? But that's kind of, the lack of security breaches, as logical as it sounds to technically minded people, can sometimes be a very difficult goal or a difficult metric to sell to business people. So it's all just a little bit a lack of understanding of what is the fundamental goal of things, and that tends to be a lot of friction within companies, right? Because the defenders have to be a little annoying at times, creating policies and things that might slow some people down. For example, making it a requirement to use two-factor authentication, right? Not everyone is happy about that because that means people need to carry either a hard token or they need to find their phone when they want to log in. But as time goes on, I think us as a community of people and users are starting to accept that that is just a trade-off that we need to make because it protects us greatly, many times over the amount of effort that it takes to actually get along or put up with two-factor authentication. But again, making that happen inside of a company can sometimes cause a lot of friction. So you're constantly fighting political battles, and it can be tiring. And I do not envy people on blue teams. I've been a blue teamer myself for a couple of years, and yeah, it's it can be tough at times. I've pretty much covered all of this. Yeah, also mainly a good point that I've not mentioned are budgets. Right? Oftentimes you are constrained by how much you can spend, and usually the situation is you feel like you're never spending enough on defense, and again, it's hard to justify extra budgets for things that are kind of invisible, like cyber defense. A lot of very smart people have thought about defending organizations from cyber attacks before, obviously. And a lot of very smart people have put together books and papers and methodologies that you can use to gain some knowledge from and transfer that knowledge into your own organization and essentially attempt to capture that knowledge. It is a Herculean task, though. Some of those methodologies can be quite rigid and maybe even difficult to implement. So when our former colleague Anand asked on Twitter, because he's got quite the following on Twitter, so he asked a lot of different people from different places, how do you manage your defense? And he gave a couple of options of fairly well recognized frameworks. But as you can see, most people just went for the, I just do whatever, which is a bold strategy. Again, that is kind of reinventing the wheel a little bit. Like you're going to struggle with the same things that all of those people have struggled with and have it described in their frameworks. So to put the money where our mouth is, we're going to be showing you a fairly simple methodology that we have. Essentially, we're going to be splitting everything into 4 steps. Those steps, 2 are proactive and 2 are reactive. So I can essentially draw a line here, and everything above this line is proactive. So essentially learning about our own environment, making sure that there isn't anything that we, making sure we limit our blind spots, making sure that we know of all the things that we have in our environment and that need to care for. And then we're going to be discussing on how to care for those things. So those steps are proactive. You're hoping that those will deter attackers. But should anything actually happen, then it's important to have some steps to think about when the attackers already breached your defenses. Right? So we're going to be talking about detection. We've already talked a little bit about detection in the Kubernetes section, but this time will be a little bit more generic about cloud specifically, so not just Kubernetes. And we will be also looking at a response section where we'll be discussing how we can react to being hacked and how we can make sure it doesn't happen again. Okay, so let's start with identifying things that we have. So obviously, it is very difficult to protect assets that you do not know about. Luckily, this is quite easy to do in cloud. And by it being easy, I mean learning about things that you have. Because after all, the cloud vendors, they need to keep very good tabs on what you're actually using in your cloud subscription, because at the end of each month, whatever you're using is going to be a line on an invoice. So it's in their best interest to keep very good track of all the different services, of all the different machines that you have running, of all the different Lambda function invocations, like literally everything. And as a byproduct of that, we as consumers get to use APIs and cloud native tooling to also provide us with information about what we have and give us the option to inspect what we have to some extent. Now we can see what kind of EC2 instances we have, for example, we can run some rules and compliance checks on the entire inventory, as we will be doing with a tool called AWS config in a minute. So we get to reap some of the benefits of this integration as well. So this should be, the odds are in our favor as blue teamers, right? Because we have full access to the control plane. There's going to be zero guessing involved. There's no real enumeration. It's really just using the tools that we have in our disposal. So take an inventory of your cloud assets. It's really not just the virtual machines, right? It's not just the EC2 instances. There's a lot more to it. Any kind of cloud service that you are using is a part of the inventory. So all of your beanstalk deployments, all of your Lambda functions, all of your software as a service subscriptions, so RDS instances and things like that. Your DNS is an asset that you need to care about, right? Because keeping it up to date is generally a good idea to make sure things work. But also removing things that no longer exist from DNS is important, right? Because if you leave an instance running somewhere and you kind of forget about it, and it's still hosting it's still got a virtual host on it that's hosting a vulnerable version of WordPress, and you still haven't removed it from the DNS, there's a good chance that someone's going to find it. So yeah, don't leave dangling things in DNS. Think to the CNAME records that point to places on the internet that you maybe no longer control. Those can be turned against you. Also, all of your access control settings, so things like users, policies, groups, roles, all of that is a part of your cloud inventory, and you need to make sure you have a good idea of what you actually have. So for example, if you've got a lot of roles in your account that you no longer use, it's probably a good idea to get rid of those. You don't need those in your account. Better to not have them rather than risk someone assuming those roles or passing those roles to resources and escalating their permissions that way. And maybe kind of annoyingly, but this unfortunately is not a one-off. This is something you will have to keep doing over and over and over again, which isn't fun. But luckily in cloud, the 99% of this can be automated. And you do not have to put in much effort to make sure this happens over and over and over again. You can have automated solutions scanning things and notifying you of changes. So as I said, there's a lot of automation to be had, and that should make our lives a little bit easier. So I've been giving you a couple of examples with AWS, but I've mentioned the AWS config tool, which is something we're going to be looking into in a minute. But that's obviously not the only tool, and obviously it's not AWS specific. Every single cloud vendor has dedicated APIs and CLI tooling to help you identify what you have in your environment. But AWS config is a particularly nice tool that I enjoy working with. So we will revisit this actually in the later section. I'll show you essentially a demo of how it can detect changes in your environment, how it can let you know, and how it can even automatically fix things for you, which is a very intriguing prospect, I would say. So when it comes to GCP, obviously there's also an API. There's always a set of tools that we can use and leverage within any of the big cloud vendors' environments to list things that we have, be it just the standard gcloud command usage, or be it the asset subcommand that we can use to literally facilitate take an inventory of your assets. Within Azure, there's even a whole class of commands with RM in the middle of them, RM standing for resource management, aka take an inventory. And if you are in a multi-cloud situation where you've got a lot of environments to take stock of, this can be tiring. So that's why that's why there are third-party solutions to essentially help you monitor multiple environments at the same time. We will be looking into multi-cloud tenancy. During the rest of the day as well, I'll be showing you a centralized solution called ELK that can ingest logs from different places, essentially making it slightly easier for us to read logs and aggregate events and things like that. But when it comes to taking inventory, there are also third-party solutions that you can leverage to, again, make the job a little bit easier. You don't have to be dealing with AWS and 3 accounts in GCP and so forth. You can automate a lot of this. I'd like to make a slight remark about something called shadow IT or dangling assets. Essentially, this isn't a strictly speaking technical challenge, a technical problem. This is an organizational issue. Typically, if you have a company which has some cloud assets and you make it difficult for developers to ask for new resources or extend resources that they already have, you might find yourself in a situation where the developer chooses to, instead of filling out paperwork, they just sign up for an AWS account because you get 750 hours of T2 micro runtime per month for free, meaning you can run a instance, a small instance, but it's still an instance, it's still a server, and you can run it for a year for free. It might be feasible for that person, but rather than do paperwork and explain to three middle management people why they want to do something. It's just a cost-saving measure for them, right? It's not that they don't want to do it, but when you take a look at the time that's going to take and all the reasoning and all the energy, it is sometimes just quicker to pay for something yourself. Sometimes you don't even have to pay anything. Like for example, with AWS, if you create a new account, you are eligible for the free tier usage for a year, and you can use a good chunk of AWS services for essentially free. The problem is that if that developer comes up with something interesting that then gets a lot of use internally from your organization or contains some company data because people just assume that it's within the control of the company, it can be very dangerous, right? Because your blue team tools and your inventory taking skills will not reach these assets that lay outside of your organization and that are in control of particular people that either still work for you or maybe worked for you in the past and have since left, and with them they've taken the control of those assets, and it can put you in a pretty tricky situation. So we need to be very careful about this. And again, this isn't a technical issue, it's an organizational problem. So the only thing you can really do about this is try to make your internal processes as smooth as possible, to not have many roadblocks that would cause people to just ignore the process and rather just subscribe to AWS themselves. For example, I was very lucky to work for a company in Prague, which had this pretty interesting policy where if we needed to spin up some services or servers and infrastructure, we could do it on the company's account, and we essentially would get 2 weeks of runway during which we could experiment and build things and test things out. And if after 2 weeks, whatever we built or whatever the idea we had made sense, then we could talk to someone and say, hey, look, I made this thing. Here it is. I think it's really useful. All my colleagues agree. Can we keep it? And the answer would most definitely be yes. But also if during those 2 weeks, you realize, oh, you know what, this idea sounded better in my head. It actually doesn't make that much sense when I bring it to the real world, then no harm done. You can just, stop everything and you don't have to justify yourself to anyone. So essentially get those 2 weeks of runway without any process, without any paperwork, without any email chains and calls and conferences, explaining your actions, right? And I thought that was really great because it allowed for a lot of innovation to happen really quickly without much friction and without the risk of the company being in a position where they don't control their own assets, because that is a very dangerous and a very slippery slope as well, because that can spread really quickly and it can put you in a pretty bad position. Okay, so with all of that said, we will now take a look at an exercise that we've called Identify. And essentially, because we're switching gears, we are now providing you with high-level access, or highly provisioning you with quite a high degree of access to a set of cloud environments. So not just AWS, but also GCP and Microsoft Azure. And during the rest of the day, we will be primarily using those credentials. So even if you're just watching this as a demo, please make sure to actually follow up on setting those credentials, because we will be using those, for example, to pull down some container images and run some auditing on those images and so on. So the credentials that we're going to be setting up in this lab will come in handy for the rest of the day as well. So that's pretty much the goal of this lab. We're going to set up some access and use some cloud native tooling to essentially just enumerate environments that we will be revisiting for the rest of the day. Okay, so I'm switching back to my VM here. Let's take a look. Okay, I need to clean up a little bit. Okay, this is fine. All right, so I'm going to be providing you with some credentials you can use to access AWS. You can just simply copy paste those in. We're going to be sticking to US East 1 region. Let me just make sure that I have set those up correctly. Yeah, okay, here we go. So we are a user called Sec Auditor, which in itself is a hint as in what kind of permissions we're probably going to have. We are a Sec Auditor within the Victim.Cloud AWS account, and we can essentially take a look at what we can do and what we can find inside of this environment, because we spent 3 days attacking this environment and now we're in it as a legitimate blue teamer. So there's no guesswork, there's no attacks required, there's no guessing, there's no enumeration. We can just use native legitimate tools to essentially learn about the environment itself. So I can take a look at running EC2 instances, for example. Again, because AWS is quite regional or region specific, it could be annoying to do this per every region. So we do have a one-liner here that essentially lists available regions and then follows up by performing some basic enumeration against those regions in terms of running EC2 describe instances. Again, not very much in some of the early regions, but I promise you there are things in this account. Just have to find them. I think because yeah, okay, here we go. So there are some instances in AP Southeast 2A, and essentially this is going to continue. This enumeration is going to continue with finding even more information. So this lab is more meant for us to kind of get acquainted with what we have going on in this account, because we will be revisiting this throughout the rest of the training. So, giving a brief look to the S3 buckets, looking at existing Lambda functions, things like that. While that's going on, I can get the Microsoft Azure side of things started. So for Microsoft Azure, we will be using the Azure audit account that we have enumerated the password for on day 2. Yeah, day 2. So we'll be using this account to essentially look around the Microsoft Azure estate. So I can do AZ VM list, look through all the virtual machines we have running. I can take a look at all these storage accounts that we have. So things like victim assets, victim public, private, auth, and so on. I can check out if we have any Azure functions. I don't think we do, no. Let's do the same thing for GCP as well. And here's the little bit of setup that comes in. For GCP, we're giving you a file that contains access to a service account. So you need to create the file locally. The contents are in MD books, in the training portal, I mean. But you just have to create it yourself and activate it. So I'll show you how to do it. I'll first create the file here, paste in the service account details from the training portal, from the write-ups, save it, and activate the credentials. So I'll say gcloud auth activate service account from this particular file I just created, and it should give me a success message. And I'll also set up, I'll tell the gcloud command what kind of project I'm talking about, otherwise it's going to be a little unhappy. And once I've done that, I can use the gcloud command to essentially look through things I can do or things that we own in this account. And I quite like the output from the gcloud command. It's quite nicely formatted by default. I mean, this, like by default, is just so much readable than this. I mean, there's just a bunch of JSON here. This is really annoying to read, whilst this is just so nice and succinct. It's very similar to running things like Docker PS or kubectl get parts and things like that. It's just such a better, more sort of sensible way of presenting things to people. I think more tools should by default behave like this. I'm completely fine with having a switch to something like a JSON output, but this makes so much more sense when you're looking at things in a terminal. So we can be looking at compute instances. We can check out what kind of buckets do we have. We can check out any kind of cloud functions that are available in our account, and so on. Okay, so I'll let you explore those environments a little bit. Get a little bit familiar with those because we will be exploring those further today. So I'll put some time on the clock, and we will continue in about 10 minutes. So good luck. All right, so that was 10 minutes. I hope you got familiar with the cloud environments. So that essentially concludes the first step, really, in our defense methodology. Just take an inventory, understanding what you have so that you can apply adequate protection to it. So in this next module, we will be talking about how to protect things that we have. So because cloud is quite a young technology, I would say, relatively speaking, hard to define what is young and what isn't, but it's not been around for that long. And as such, a lot of the development has been done with past knowledge and built on security principles and made to be secure by default wherever possible. Obviously, there are some edge cases, but when you compare this to how we secure things on premise, the cloud is clearly in a much better position, just because how centralized it is, how easy it is to roll out new changes, and how rapidly things can develop and change for the better. When you look at, I don't know, if you look at Windows, Windows is such a huge part of any company infrastructure, and yet we still store passwords as NTLM hashes, which are just crazy, just really not a good thing to do. Storing passwords as NTLM hashes. As we've moved past that in the web app sphere many years ago, but we're still doing an equivalent of something quicker than an MD5 hash in a Windows environment, right? In a cloud environment, we have moved past all of those issues, and we can really rapidly change things and develop new things. So the baseline level of protection is already quite high, and a lot of services are secured by default. If you want to make something, for example, if you want to make an S3 bucket public, you have to go out of your way to do that. Like, you have to click through multiple dialogues that explain to you what you're doing could be dangerous. And if you are really, really, really sure you want to do it, you have to type out the name of the bucket and type confirm. And it is really annoying. And that's by design, right? To make you really unlikely to accidentally publish something you didn't mean to publish, or accidentally misconfigure something, essentially. All of the defenses that you apply to your infrastructure should also reflect the fact that they're there to help people. And the main purpose of the blue team is to protect things, right? It's not to annoy people, but sometimes it's hard to draw the line. So obviously, making people use 2FA is completely fine, but making people constantly change their passwords and implementing a crazy complexity policy, that's going to be viewed not as a good thing, but as a bad thing, as a roadblock, essentially. And when you put a roadblock in front of people, instead of going through it, people will obviously go around it. So when you force people to change passwords every couple of weeks, people will get irritated, and they'll get a pack of sticky notes, and they'll write the password on the sticky note, but they will not put the sticky note on the screen because it's not the 90s. They will put the sticky note under the keyboard. That's where you put passwords in 2022. So if you want to avoid that, you should tone down some of your more radical recommendations, and just make sure that you don't upset people too much, because if you pressure people too much into good OPSEC, good operational security, people will generally find ways around it, and you will be worse off than when you started. Something that I'd like to mention is the principle of least privilege, or the least privilege principle. Again, this is something that's really hard to achieve. It is kind of a moving target, really, and it's something that you should strive for, but you need to accept that you will probably never achieve perfect principle of least privilege, meaning like you've really locked down every single thing you could to the least, to have the least permissions for it to even work. But it is something that you can use, for example, when you are creating new software projects, when you're working on something and you're developing a service or a solution, or whatever you're doing, typically what people tend to do is they, on a scale, if we'll view this as a scale, between, everything is allowed and nothing is allowed, people, broadly speaking, start on the left-hand side here. And if there is time during the development lifecycle, they might put in some security features, remove some unneeded access, make sure the software runs without root permissions, and so on. But they will generally not get very far with this because there's never enough time. There's always too much pressure, release dates, sprints. There's always, things to do. So usually you don't get very far. But if you take a look at it from the other side, if you start with a system that really doesn't have essentially any permissions, and every single time you need to do something, you invest the time into allowing just that one thing. Right? You start, for example, with, I don't know, a container with a read-only file system. And then you say, well, I need a place to cache things, so I need to mount one directory to be writable, but I'm going to make sure that there can't be, PHP scripts in that directory that can be executed, and so on. And maybe I need to have a super user account that performs this one action, but I will make sure that people can use something like sudo, but they can only run this one particular command. They can't just escalate their permissions altogether. And you can essentially keep relaxing the security constraints and conditions, and you might end up, for example, somewhere around here. Right? But that's still much, much better than if you were to start here and only move back towards low permission state and end up around here. So that might be a methodology you want to use when you are developing projects, when you are supervising projects, as a good thing to do when the thing is being developed. Because once the thing is developed, once it ships, that is it. Like, no one's ever going to fix anything in it. Or maybe yes, but not very much. There's never going to be any brand new breaking changes unless there is something in it for the company. Like, you're never going to have enough time to pay off the technical debt you have acquired throughout the project, right? So it's better to start from this side and move towards the left-hand side rather than the other way around. When it comes to the cloud control plane, you should make sure to never use things like the AWS root account or the tenant admin or super admin in GCP, simply because those accounts cannot be restricted in any way, just by design. That is not a thing you can do. And also, those accounts are typically not tied to a particular person. So, if multiple people share these credentials, then it can be very difficult to point the finger, like, who did it? Was it you, or you? And everyone says it wasn't me. And it can be very difficult to resolve a situation like that. So again, that's another case why you really should never be using a root account or the highest privileged account in your cloud subscription, simply because the credentials are just way too sensitive. And if they get out, you can recycle those credentials. You can revoke the credentials and ask for new ones, but you can't temporarily restrict the account. Right? It's still going to be there, and it is unrestrictable by definition. So you really never should be using the root account. Like, you should be using it when you create your account, you sign up for the service. You can create some admins, you can set up budgets and alerts, but then that's it. You should probably leave the account alone for almost forever. Delegating tasks to lower tier users and administrators for specific services is a much better way to go. And make sure to protect those accounts sufficiently, for example, through MFA. So that was the control plane. Now looking at the data plane and things you can do in the data plane. So logging is a very big part of it, because you can't really detect things that you don't log for. And the post-mortem of a cyber attack being executed against your company means that if you do not have the logs, then probably the exact same attack is going to happen in future, and it will catch you just off guard as the last time it happened. So making plans for logging things, ideally somewhere external, where the attacker has no way of wiping the logs. Because once again, if a cyber attack does occur against your corporation or your environment, then the only way you're going to find out what actually happened and even have a chance at finding the root cause is through logging. So you need to make sure that the attackers aren't going to destroy the logs and sweep away their footprints. When it comes to encryption, both at rest and at transit, there really is no excuse not to do it, especially in cloud, because for most resources in cloud, using encryption, especially encryption at rest, is literally as simple as ticking a box. Like, it really doesn't take much effort. It takes absolutely minimal effort. So all the excuses as to, oh, it's going to slow everything down and it's difficult and we need to rotate keys and do this and do that. No, there's no excuses. Encrypting things is, especially at rest, is really easy in cloud because the cloud vendors can take care of rotating keys and doing transparent encryption, decrypting things on the fly. There really are very few reasons not to do it. When it comes to running services that maybe are not 100% necessary or should be restricted to some subset of your overall ecosystem, you should do that on the level of the service, right? You shouldn't be relying on things like network policies and firewalls and security groups and things like that. As we've seen in the entry number 3 exercise, by dealing with the exposed MongoDB instance. Again, if I have a service that I need to be running internally, I can just make it listen on an internal interface. Like, I don't need to have it listen on every single interface there is. In fact, I really shouldn't. I should restrict it to, again, the least attack surface possible. So only listening on an internal interface where I know traffic is going to be coming from sets me up for success in defending that service. Because even if the firewall fails, even if someone misconfigures a security group or something like that, the service isn't even listening on a public IP address. Therefore, it can't be attacked from the public internet. If you do deal with low-level offerings such as EC2 instances or Google Compute Engines and things like that, if you're building your own systems, make sure to use some hardening steps in whatever you're doing. So I'm just reading a question. Encrypt where possible. For storage encryption, which is more preferable? Instance deployment or container or the sensitive files? Okay, so I meant more from the cloud perspective. So for example, I have I've got an EC2 instance and I have taken a snapshot. That snapshot is going to be sitting on my sitting in my AWS account, and I should probably make it be encrypted, right? It probably shouldn't sit there in clear text. When it comes to the container side of things, that's a little bit more difficult because container images are typically stored in a repository somewhere in a registry, and they're pulled down during runtime, where encryption is not, I don't want to say impossible, but impractical really, because of how the containers function, right? You've got a little dedicated structure on the file system that you're using actively, so you can't really encrypt that unless you encrypt the entire file system. And oftentimes with managed services like managed Kubernetes services, you might not even have an option to do that because you don't control those instances or because you don't have a checkbox to tick. So with containers, that's a little bit more difficult to give good advice. But for example, when you deal with logs, right? So logs should be stored encrypted, right? There's no reason not to do it. it's a lot of data that just sits around, and really it's no one's business what's in those logs, right? Apart from you, if you need access to those logs, right? So that's a great candidate. And some auditing tools that we'll be using later today will call you out on, for example, having CloudTrail logging, but not having it encrypted. Yeah, also encrypting where possible when data is in transit. This is something you can implement yourself, right? Say you have a cluster and you have a database in the cluster, you're running like a daemon set or something like that, and the database talks to an API server on the backend, right? And vice versa. This communication is going on across the cluster, possibly across different nodes. Pretty much all relational databases and even NoSQL databases support TLS, right? So this communication should be protected by TLS, right? So encryption during transit is also important. So it's not just about encrypting like, a config file somewhere. That's probably not going to do you much good, because then you have the problem of where do I get the encryption keys from? Again, like wherever it's feasible, really, right? Yeah, I feel like just saying encrypt everywhere is maybe too radical. Encrypt everywhere where it's possible and where it's feasible. But encrypting specific files during a container runtime, that's probably taken it a little bit too far, I think. But I don't know, maybe it depends on your use case. Maybe you really need to do that. That's fair enough. But I would focus on other areas. For example, data in transit in a cluster. Okay, cool. So, another point I'd like to make is automation versus doing things manually. There's nothing wrong with doing things manually, but if you take this scenario, right, you have a small company and you are setting up a server that's going to handle whatever business model you have, whatever services you're offering. You're going to have a server. And as your company starts to grow, you need to add another one. So whoever set up the first one is just off memory going to try to set up the second one in the same way. But then, then the company keeps growing more, and suddenly you need to add 2 more servers. And then it gets a little bit difficult, right? Because the person who did it the first time around and second time around, maybe they've gained a little bit more experience in what they were doing, and they think, okay, I'd use a different distribution and I'd do this differently, and I'll put those config files in here instead of there. And all of a sudden, you have a super divergent infrastructure, right? Every server is a one-off, and that makes it really annoying to deal with. Especially when you need to, for example, do some assessment on those servers, right? So say you get a security professional to come in and help you review your hardening steps on your servers and make sure there's no bad open things available to attackers. If every single server is a one-off, then that security professional is essentially going to have to do the assessment, 10 different times for 10 different servers, which is going to be fairly time consuming and therefore more expensive. So having some automation, or having as much automation as possible, like using Vagrant or using Terraform, using Ansible to provision things, is highly advisable, right? So aiming for automation as opposed to one-offs. For example, your production servers. If you allow, if you're running a web app in production and you're allowing developers to just SSH in to your production service and do hotfixes, that is, maybe with good intentions, but this is a really bad path because someone's going to mess up, some creds are going to leak, or there's going to be a mistake in prod, but completely untested. The hotfix is going to backfire. There can be a lot of issues like that. So removing SSH access in production is maybe highly advisable, right? It's better to do the hotfix, but push it through quick testing and deploy it automatically from, like the staging environment, for example, to promote it from staging into production, rather than doing a quick hotfix somewhere, which again is very prone to errors because you're working under pressure, you don't have much time. So essentially aim to remove this manual intervention wherever possible. I've already spoken about some of these tools. So for example, when you are setting up new servers, using things like Terraform to define your infrastructure and provision machines through Vagrant and build machines that way. And when you have built the system itself, using something like Ansible to manage things is really, really important. As soon as you have more than one server, this becomes paramount, because otherwise it's just going to be a mess of trying to track what's different on server 1 as opposed to server 2. And when you start adding things, it's just going to snowball. So especially machine provisioning should be done in a fairly centralized way. Okay, another topic to discuss, financial protection. So sometimes, you'll see crazy news titles like insurance companies now allow you to insure yourself against ransomware attacks, which is insane. I mean, you can, if you run a company, then you can bet on the fact that you are going to get infected with some ransomware, and instead of taking some money and investing in a blue team that could catch that early on or mitigate it fully, or just do a lot of triage and help you minimize the impact. Instead, you choose to pay an insurance company, and you just wait. You're just waiting to get hacked and to claim the insurance money. That's insane. I'm sure there are some smart people around that have their reasons for doing that, but from my technical standpoint, that sounds like money not well spent, and I'd much rather invest in the actual cyber defense of my company. But I'm going on a little bit of a tangent here. Financial protection takes many places and many forms. But for example, here someone on the internet is saying, "Hey, I got hacked," and instead of ransomware, people essentially started to spin up machines in AWS and mine some crypto on those machines. What do I do now? I suddenly have a crazy bill. How can I not pay this bill? And usually the answer is, unfortunately, well, you're going to have to pay up, right? Because AWS, they own the hardware. You rented it for a month. I mean, it was the attackers on your behalf, but it was still your account. And as far as AWS is concerned, those machines were being ran like to the limit, mining a lot of crypto for whoever did it, whoever attacked your account. And it isn't AWS's fault that you misplaced your credentials, right? That's kind of on you. So unfortunately, stories like these don't really end very nicely. And really, there's very little incentive from the provider side of things to waive your fees, because you were effectively using a lot of resources, and someone needs to pay the bill. So how to avoid having a $50,000 bill at the end of the month? I've already talked about budgets, but yeah, budgets. Set up budgets. It's very easy to do. It is genuinely one of the only things you should be using a root account for, setting up budgets. That is, unless you choose to delegate those actions to other people. But you need to be very careful with that, because if an attacker gets in and they have the permissions, to change budgets, then they can disable the budgets and continue mining. So you need to be very careful delegating budget management and billing alerts management. You can choose from different kinds of budget monitoring. For example, you can set a fixed amount. You can look at sort of real-time spending. So for example, if you usually burn through $100 every month. If within 3 days you have burned through 75, then there's something wrong, and you should probably be get a notification or get an alert that something weird is going on that requires your attention. So regardless of what environment you use, regardless of which cloud vendor do you go with, budgets and billing alerts are necessary to be set up and highly, highly recommended by pretty much anyone you ask. Okay, this is quite interesting, the multi-account strategy in AWS. So in AWS, it's quite common that a single company will have many different accounts. And you can even group those accounts together through something called AWS organizations, which gives you centralized billing and some control over all of those accounts to essentially manage them a little bit. And this is really great for separating things and making sure things are contained, right? So if you have an account for a development environment of something, then you have a different account for staging, different account for production, and so on. If an attacker gets into your environment and they get into your development account, and even if they fully take over this account, then what are they going to do? They can't pivot towards anywhere else, right? That is, unless you have like assume role things, or again, misplaced credentials or sharing passwords and things like that. But if you don't do any of that, then the attackers will be contained within this one account, and they will not be able to spread to, for example, production, where you may have a lot of sensitive customer data. So that's why the multiple account strategy in AWS is quite popular. Another great use case for this would be when I was talking about having logs somewhere separate. Let's just have an extra account here for logs, right? We can set it up so that, well, it's a bit of a weird cloud. We can set it up so that all of those accounts can write to it, but they can't read from it, and they don't have the permissions to do anything else, right? They can send logs towards this account, but they can't read, they can't delete, they can't do anything else rather apart from just writing to this bucket, or writing to this account, I meant to say. So that could be a good way of making sure the attackers can't wipe the logs. When it comes to network security, you also have many options, right? You can configure things on many different levels. You can do, for example, host-based firewalls on your machine instance itself. You can mess with security groups and make sure that they're as restricted as possible, like that only the absolutely necessary things are being whitelisted. You can take it a step further and look at network access controls, make sure that those are as restrictive as possible, and so on. Essentially, there are many different levels where you can inspect network traffic and decide whether things are good or whether things are suspicious or even outright bad and should be cut out of your network flow. So a big thing to monitor on the networking side of things is the metadata API, the root of all evil, the target of many, many attacks. Like metadata API featuring many attacks when it comes to the cloud, and as such, really should be protected as much as possible. Again, the overall situation has developed very positively over the years, with GCP essentially dropping the versions of their metadata APIs which had some security issues. Again, this isn't that long ago. This isn't even a year yet that these old metadata APIs were finally deprecated and finally truly removed. With AWS, there really is no incentive. It feels like there's no push from AWS for customers to switch to the new and more secure version. They just allow you to make your own mind. And actually, they kind of steer you towards not changing anything. Because when you're spinning up an EC2 instance in AWS, and you are choosing whether to use the which version of instance metadata to use, if to enable it at all, you typically get like a little suggestion box. And if you say, okay, well, I don't need metadata, let's disable this completely, you get a warning saying, hey, this could potentially limit what you can do, and maybe your applications aren't ready for this. You should probably keep it enabled. So it's kind of steering people to just go the path of least resistance instead of go the path of least privilege, and keep the metadata APIs enabled, and also keep both versions enabled, which unfortunately makes no real sense. Like that's great for maybe transitioning from V1 to V2, but just as a regular instance, that really doesn't make sense, because even if you are using V2 only, if an attacker gets in, they're obviously going to go for V1, not V2, because that's going to be easier to exploit. Some interesting defense in-depth measures that you can use when you think about infrastructure as a service machines. Because you are in control of that machine, you can configure the firewall. So for example, if I'm on an EC2 machine and I've got access to IP tables, as a blue teamer, I can set up IP table rules that monitor the output, the egress from this machine. And if someone is trying to communicate with the metadata API IP address, so this is an outgoing connection, right? If whoever that's trying to initiate this conversation is, if it's not root, then I can drop those packets, right? I can prevent this communication from happening. So essentially only the root user is capable of communicating with metadata APIs from this machine. And then if that is a little bit too strict, you can essentially flip it around, and instead of a whitelist, you can use a blacklist, which is not advisable most of the time. But even this blacklist is most likely better than nothing. This blacklist essentially says, again, if there is outgoing communication towards metadata APIs, and the user or the account which spawns this communication is Apache, then make sure that communication is not allowed through. And this makes a lot of sense, right? Apache typically doesn't have much to say to metadata APIs. And it is highly likely that if Apache is making outbound connections to metadata APIs, that is because there is a necessary vulnerability in your application that some attackers are using to talk to or essentially coerce Apache to talk to metadata APIs. So blocking that on the host firewall level could be interesting. Even if you never expect this to happen, vulnerabilities get discovered all the time. So even if you are using a well-tested piece of software, we've seen this with Apache web server, right? Last year with the strange issue regarding path traversal that took 2 releases to get fully fixed because they've botched the fix. Yeah, vulnerabilities pop up all the time. So why not do some defense in-depth techniques like this, and possibly prevent a breach from happening with one command, right? With one IP table rules. Right. Yeah. So I've been talking about metadata for a while now, but yeah, with AWS, the continuous support of the older version is worrying. And you should strive to only support the new one if you need it at all. Like lots of places really don't need the metadata APIs whatsoever, but they are enabled by default. Right, so you can get rid of those. You can get rid of metadata APIs. For example, when you're booting up an instance, you can specify that you do not need metadata API for this particular instance. You can always change this later. You can change your mind later on and change those options around. But you can start with the metadata APIs being disabled, for example. So if you do regularly deal with low-level offerings where you manage the entire stack, manage the entire VM, you do need to take into account lots of assumptions about the security of that solution from sort of a sysadmin level, right? So you need to make sure that you're on top of updates, that any kind of services you have running are properly configured, and so on. Like all of this is in your hands, and you need to make sure that all of these tasks get done and are reviewed appropriately and just managed over time. When it comes to web apps and web services, there are methods that you can use to make things you develop more secure. A typical resource would be the OWASP ASVS. This is a very interesting project. And again, this is one of those points where if people know OWASP, they either know it because they're a pentester and they know of the top 10, or they know it because they are a developer or an AppSec person that knows ASVS. ASVS stands for Application Security Verification Standard. And what it is effectively a PDF of about 60 pages. And it essentially is a list of recommendations for building things. Let me actually show you what I'm talking about. So let me just quickly Google OWASP ASVS. Here we go. Let's grab the latest release, stable release. Here we go. Oh my God, that's, can I just get a PDF, please? Here we go. Oh my God, I hate Chrome. It just downloads it. Sorry, 1 second. Let me fish it out. Here we go. And there we are. Okay. So this is the document I was talking about, ASVS. It's got about 70 pages. It's getting longer as time goes on. So this version is from autumn 2021. And essentially, when you skim through this, it will tell you how to use this document. So you've got different levels, right, depending on what kind of application you're developing, or like where you are in the design process. You can decide like how much quote unquote security do I need? You know, am I coding something for a bank, or am I making Twitter for cats? You know, Twitter for cats is just going to be pictures of cats. Like there's not going to be a huge security risk, probably. But making something internal, for example, at a financial institution, you might have to take more precautions and be more careful. So essentially, you can pick a quote unquote level of security, one through 3. And then essentially, if you just go through the document, it gives you a lot of ideas into how to build things, right? So it starts off with things like architecture, threat modeling. Then it goes into assumptions about authentication, like what kind of password policies should you have? How should you store credentials? How to deal with forgotten passwords, and how to maintain that cycle of, okay, I forgot my password, I need to reset it, but making sure that process is as secure as the password itself. Session management, access control, cryptography, verification, input validation, data protection, like lots and lots of different recommendations that you can implement when you are building systems. So to give you an example, if I go down to password security, for example, it tells me that it doesn't talk about complexity here. It just talks about password lengths. Because it's arguably, and again, this is quite an argument. So I don't want to get into an argument with you, but I'm a firm believer that it's better to have a longer password that is maybe not as like, it doesn't maybe contain special characters, or like doesn't have a crazy complexity to it, rather than having a really short password with exclamation marks and digits and so on. because those passwords are difficult to remember and you're likely to just write them down, as opposed to if you use something called a passphrase, where you come up with like a sentence, and you may throw some digits in there, or some punctuation, for example, but that's going to make it very difficult to be brute forced. Like most attackers use word lists based on commonly used passwords and commonly used words, and derivatives of those words. We've seen that on day 2, where we even generated one of those word lists. But if you think of like a sentence, like full-on sentence, like starts with a word with a capital letter, or maybe it doesn't. There's spaces, there's punctuation, there are exclamation marks. If you speak more than one language, you can mix languages as well. Like that's going to make it really difficult for anyone to crack, nearly impossible if it's like a full-on sentence. Versus coming up with a 7 or 8 character password that's got exclamation marks and @ signs, lowercase, uppercase, digits. That is almost impossible to remember, but you can remember a sentence, right? That's easier. And that's kind of what this document is following up on. It's saying like make passwords at least 12 characters long, but don't go crazy. Also use an upper bound. And when you think about it, that also makes perfect sense, because the hashing algorithms we typically use and recommend for use should have a scalable difficulty to them. So they shouldn't be too quick, but also shouldn't be too slow, so that they can really slow down your server. But they shouldn't be really quick. They should be, there's a middle ground to be hit. But you should be also putting upper bounds on passwords, right? Because if you have this kind of slow algorithm, and as a malicious attacker, you create a special HTTP request that sends like a gigabyte of data as the password. And then your server is going to start hashing a gigabyte of data through a really slow algorithm that might cause a denial of service condition. So this document is very clever in all the tips and tricks that it walks you through, and it tries to guide you to what the community takes as the best approach. So I highly recommend to check out the OWASP ASVS if you are building things. If you are in a solutions architect position or application architect position, ASVS is a really good resource. They also have one for mobile applications as well. Further reading resources, if you are interested. There's much to read. There's always too much to read, honestly. Okay, I think we're getting really close to a coffee break. So I think we're going to take a coffee break now. And after we come back, we're going to continue with discussing the defense methodology here. And we're going to switch from being proactive to being reactive. So I'll show you how you can detect things, monitor things. I'll show you things like the elk stack and so on. And I'll also be showing you how to audit things at the very end of the day. But for now, let's take a coffee break. Let's rest a little bit because I've been talking with you for a while now. And I will see you back in about 20 minutes. So enjoy your coffee break, and I'll see you soon. All right, so that was the last coffee break. I hope you enjoyed that one. The ultimate coffee break. Okay, so we've got a couple of slides left and about almost 2 hours. So I'm just going to continue. I'm going to walk you through the rest of this methodology, and then I will show you a couple of interesting tools when it comes to auditing. I'll show you some tools regarding auditing cloud environments. I will also show you some tools to audit Kubernetes environments. But first, let's talk about detecting. Sorry, 1 second. Sorry about that. First, let's talk about monitoring and logging cloud events. All right, so we will be taking a look at what we can monitor inside of a cloud environment that might give us an idea of what's taking place and how we can react to it afterwards. So I'm a little hesitant to always give out like a list of things that I think are important, but nevertheless, here is a list. So whenever someone changes their password or rotates their keys, that should be logged. Maybe depending on if you're developing your own system, maybe depending on how sensitive that system is, you should probably let the user know as well that someone, probably that user, but someone has changed the password on that account, or that someone has rotated a key. And if the user doesn't recognize that activity, that they should click like a special link and make sure to reclaim or secure their account. Any kinds of configuration changes, so changes to the environment, that needs to be monitored. Like, because if an attacker gets in, some of the first things that they might want to do is do things like disable CloudTrail in AWS, so they are not as monitored as before, right? So that is a very clear and very crucial configuration change that needs to raise an alarm, because that is unusual. If you are dealing with web servers, the access logs could shine some light in case the breach came through the web server, which it oftentimes does. And again, most of these are fairly self-explanatory and just common sense, really. But one that you don't see too often is reactions to, one that you don't see that often is an application reacting to multiple failed MFA authentication attempts. Especially when you're dealing with TOTP codes, when you have to punch in 6 digits from your token, sometimes you do get it wrong, sometimes you don't do it in time, and the code changes, or you make a typo, or you read the digit wrong. But it is very unlikely that within the span of a minute, you are going to have more than, let's say, 20 or even more than 10 login attempts with an incorrect MFA value. That is very unlikely, and that should raise a lot of alarms, because that's clearly someone trying to brute force their way in. Depending on the length of the code, like some codes, for example, the TOTP standard actually has 2 variants. The more commonly used one is the one where you have 6 digits to type out, but there's also a version with only 4 digits. 4 digits, that's not a lot of options, right? That's 10,000 options, 10,000 possible values, and you can absolutely send 10,000 login requests per minute, depending on the server. But servers like Nginx are designed to handle 10,000 concurrent connections. So in theory, it shouldn't be a problem. And therefore, this is something that you should be monitoring for, like a spike in login activity and just someone using sheer brute force to get their way and log into an account, even though they do not possess a legitimate MFA token. They just try them all. So ideally, you do want to shorten the path from event source up until it is detected, processed, and possibly an alert generated. You want to shorten that as much as possible. And a lot of and all the vendors effectively have tooling that can help you achieve that. So those tools are specific to the cloud vendor that provides them, obviously. So that can pose an issue. That's kind of like a vendor lock-in scenario where you are locked into using tools provided by a particular vendor. And that's actually why we're going to be looking at alternative offerings as well. For example, when you are dealing with a multi-cloud situation, vendor native tooling is awesome, but when you suddenly have 7 different dashboards to watch, it can be a bit too much. So within AWS, the primary offerings are CloudWatch to essentially look at things as look at different resources and their metrics and performance monitoring of those resources, and also CloudTrail. CloudTrail is effectively an audit trail of things that happen in your environment. Both are important and both are useful in their own regards, depending on what you're looking to monitor. But both are fairly crucial offerings to making sure you do have sufficient monitoring and logging enabled. When it comes to Microsoft Azure, we've got things like the Azure Monitor and the Azure Security Center that you can use to perform similar tasks. Once again, the great thing about cloud native tools is that they provide you with great dashboards because they're fine-tuned to suit the environment of that particular cloud vendor. And regardless if it's AWS, GCP, or Azure, the primary offerings are always pretty good. But the problem is that if you are dealing with a lot of logs and from all over the place, not just one cloud environment, processing those logs, it's not really possible to do inside of a cloud environment using the cloud native tooling, because that is specific to, for example, AWS. So you need a different solution. So you might need to actually get the logs out of the cloud environments and process them elsewhere. So when you start to look at the actual underlying log entries, again, that's not something you want to be reading by just actually reading it, because you would probably go crazy. That is something you want to get processed by some external system. Nevertheless, the log entries should always help you answer some basic questions, even if you are reading them, just manually reading them or inspecting them. And they should always be able to answer the following questions, right? So they should always be able to answer when something happened, who did it, how did they do it, and what was the target. All right, so essentially, when, who, how, and what. Those 4 questions should always be answerable just by looking at a log entry. And even though the log entries tend to be quite big, for example, here we have a JSON representation of a log entry from GCP, this might not look like too much, but all of those blue lines where it says object or enum, those hide like a lot of substructures. So obviously it wouldn't fit on the entire slide. It had to be expanded, all of those. So there's quite a lot of things happening. Same goes for AWS and Microsoft Azure. Again, those, I mean, you can read it when you just go line by line, but again, that is not what you want to be doing. So what do we do then if we don't want to be reading those by hand, if you don't want to be reading those manually? How do we process those logs and turn them into something a little bit more interesting? There's multiple tools that you can be using for that. You can be leveraging, again, some cloud native offerings to aggregate those logs and pull out the interesting details from them. This doesn't, however, solve the problem of multi-cloud tenancy. This is still sort of vendor locked in tools, albeit interesting tools like Amazon Guard Duty and its counterparts across the other systems as well. The thing I'd like to show you is a third-party solution based on the elk stack. So what is the elk stack? So it has nothing to do with the animal. Elk are the first letters of some of the pieces of software that consist, that comprise this technology stack, right? So the E stands for Elasticsearch, the L stands for Logstash, the K stands for Kibana, and the nothing stands for beat. The beats protocol is a late addition, so it doesn't get a representation in the Elk stack acronym, but what can you do? So all of those have different roles. Essentially, the Elasticsearch acts as a database, essentially so a storage solution, and it is being fed data through through Logstash and possibly beats. So Logstash is essentially a piece of software that can help you ingest logs and parse through the log entries and essentially convert one data format to another. Like, so if there's a JSON string coming in, Logstash can understand what it is and parse it to actually create a structure out of it so that you can easily search it. The problem with Logstash is that it has quite a big footprint. And if you are collecting logs from many, many places, sometimes, Logstash would be just too much to handle for that particular instance. So we needed to have a lightweight data shipper, so-called. So that's why Beats enters the game, because it is a lightweight data shipper. And so it's essentially very good at grabbing data, grabbing log files, metrics, and so on from one place and sending it to a centralized stack that's going to aggregate all of those logs. So Beats has a focus has been placed on making it as lightweight as possible, as opposed to things like Logstash, which have more features but also much bigger footprint. So that's the sort of under the hood backend situation, right? You've got Beats that essentially can lift log files and metrics and things like that. You've got Logstash that can help do the same and also do some pre-processing on those entries. And you have Elasticsearch, which serves as the storage and a good sort of search piece of software that can do full text searches on those logs and time series and data like that. And that's all sort of happening under the hood. We don't deal with those things directly. What we do deal with is called Kibana. So Kibana is a dashboard. That's what it is. It's a highly customizable piece of software that you can use to analyze things that exist in your Elasticsearch instance, visualize them in graphs and charts and or just in a textual representation, search through lots of those logs and so on. So this is an example of a Kibana dashboard. We will have a live demo in a minute, but I just wanted to first explain what the Elk stack is and what the different layers do. When it comes to the Beats side of things, as I've mentioned, it's essentially just a piece of code that can move log files from the target system to your log analysis machine, essentially. So it can move log files, it can move metrics, it can look through Windows event logs and so on. It's got a fair bit of functionality. So if you recall, on day one, we were attacking a Lambda function. And what I didn't tell you at the time was that we were silently logging all of those requests. And all those requests that we logged, we also shipped from the Lambda function to CloudWatch, and out of CloudWatch into an Elasticsearch instance that we have running. And what I'm going to show you in a minute is I'm going to log into Kibana and visualize some of those logs for you to essentially show you what that can look like. And we also were doing the same thing for the Azure function that we were trying to compromise, but we didn't really get very far with it. If you remember, it was possible to read files from the Azure function runtime environment, but we couldn't disclose any credentials. But we could still sort of poke around and read files. And all that has been captured in the logs that we have collected. So let's take a look. Okay, so I'm loading up the Elasticsearch instance. Hopefully my dashboard loads soon enough. Here we go. Okay, so this is the Kibana dashboard. I'm going to quickly switch over to some of the data that we have captured and show you what it's all about. So let's go to function beat. And I need to change the time array here from last 15 minutes to a couple of days ago. So let's say 5 days ago. Okay, and immediately I can see a lot of records were being generated on the 10th of May, around 12 GMT. So let's take a look. On that day, there were some 5,500 hits. So a lot of traffic was hitting these endpoints. And we can go through those and look through the payloads that were used and see a lot of information about what happened and how it happened and who caused, what caused, and so on. For example, I'm getting some suggestions here, which is great. So I can, for example, take a look at the payload that were specified. I can visualize some of those. So let's take a look. Again, depends on how well you're parsing the logs. Seeing as Elk Stack is a third-party solution, it's an open source solution that anyone can deploy. But it's really, you're going to have to put in some work into customizing this, right? Because out of the box, it might not be exactly what you're looking for, but it is a very interesting solution nonetheless. So maybe I can increase this to like 15 most common values, and maybe let's not do a donut. Let's just do a boring table. Right, so I can see that a good number of people got like 94 hits here for the file //proc/self/environment, which if I were a SOC analyst, like this would raise my attention. This would get my attention because I'm getting a lot of these requests in here, reading this file, which I would deem is sensitive. So yeah, this probably requires a little bit of further investigation, because if there is a vulnerability on this website, this could be dangerous. This could be that giveaway. Someone also tried to read the passwd file. Someone was trying to reach to the metadata API service here. Someone tried to connect to our SSH port locally. Interesting. We've had someone, again, trying to connect to the metadata APIs, both through HTTP and file. So yeah, I'm getting interesting footprints here. Someone tried to do some directory traverse up here, and so on and so on and so on, right? So you can visualize a lot of this. You can set up alerts, and most importantly, you can aggregate across different environments, right? So those were mainly AWS logs, but we were also looking at the Microsoft Azure function. So if I quickly switch over there, yeah, that's fine. If I quickly switch over there, let's take a look. That's going to be, I think, either here or here. Yeah, FileBeat. Okay, so those logs have been collected from the Microsoft Azure side of things. Let me just reset the time range here so we can see where the peak was. So let's go 5 days ago. Yeah, so I can see there's actually been a peak on the 10th of May. So looking at the 10th of May, I'm essentially getting a bunch of log entries here. I can again look through the entire log entries, all the values that have been extracted from this, so I know which function was being targeted, what was the payload, and so on. I even get the full log entry coming in from Microsoft Azure. So this is the Elk Stack. Effectively, at first sight, this doesn't look as polished. This doesn't look nearly as polished as the offerings by cloud vendors themselves. And that's for a good reason. I mean, it has to be generic, right? It's not meant for a single purpose. it's a generic dashboard that helps you visualize data. So you're going to have to put in a fair bit of work to customize it to the point where it can match the, I don't want to say the looks, but it can supplement the functionality that you get from cloud native offerings. But once you get to that point, it's very easy to just keep adding new sources of information, right? So you can be pulling logs from your AWS instances. You can be pulling logs from Microsoft Azure, right? Because your company acquired a smaller company that was cloud native, but they were using Microsoft Azure. So you don't want to be dealing with those dashboards. So you just start pulling data from Azure into your existing Elk instance. Maybe you can aggregate data from on-premise as well into Elk. Essentially, it's going to give you one tool, one dashboard, and Elk is essentially the industry standard for many things. So it could be also easier to find people who understand Elk and can construct reasonable queries and can work with Elk already, as opposed to finding experts for each of those different environments standalone. By that, I mean the cloud native dashboards. Okay, there are some further reading resources if you're interested. If you enjoy reading, the AWS Security Hub is a really good resource. There is a lot to read though, so feel free to check that resource out. But I'm going to keep on moving, and I'm going to take you through the response section now. So responding to threats and possible breaches is obviously very important. It is sometimes hard to decide what to do once you detect that something is happening. Most of the time, you will sort of retrospectively detect things happening, not really during real time. Like it's not like in the movies, right? You don't get to, usually you don't catch the hacker during the act, but usually you get to see, you might see some alerts maybe the next day when you wake up and go through the logs. But even if you did see the hacker in the act, there's only limited amount of actions that you can take really. Because at that point, maybe you see the IP address of the attacker, maybe you can cut them off, but you can't really do much more than that. You can't take the website down, right? Because that will be a disruption to the service. What would be interesting, however, is if you had, for example, a honeypot set up. If you don't know, a honeypot is essentially a intentionally vulnerable piece of environment that you can essentially push attackers into, and they will find it interesting, right? Because it looks vulnerable. It looks like there's an outdated system and they can drop a shell on it. And what you're essentially looking to do is to waste as much of their time as possible, right? To discourage any kind of attacks in future. That's why you could divert people to a honeypot. It could also give you, I quite like the concept of honeypots, right? Because it gives you, you keep your finger on the pulse of the internet, right? You understand what kind of attacks are happening right now in the wild. You can use that information to make sure your blue team understands what's going on, and they have some practice, right? They can detect attacks as well. So honeypots are pretty cool, but there are some drawbacks to those as well. What if someone breaks out of the honeypot? What if the honeypot isn't coded very well? Or what if people start using it as like a bot for a botnet? There are some questions to be answered before you start deploying honeypots on your network. The really cool thing about cloud is that the response doesn't have to be made by you manually, right? This can happen sort of automatically, to some extent automatically. I'll be showing you an example of that in a second with a tool called AWS Config, which will essentially be able to automatically fix things that are broken in my environment. But yeah, to a high degree, things that are easy to detect and easy to fix can be fixed automatically. This is, again, something that you would struggle to replicate on-premise because your on-premise situation probably isn't as centralized. Not everything is made by a single company. So the interoperability of different components could pose an issue to having like a, auto magically fixing itself solution. So yeah, we will check out this AWS config tool. Obviously, there are counterparts in other providers' environments as well, but for no reason in particular, we will be looking at the AWS side of things. We'll be looking at a tool called AWS config. Before we get there, though, there are some case studies you can learn from. For example, how people preemptively detect threats. You can do that with the guard duty sort of AI, machine learning, trademark, big data, enabled blockchain using something. There's a lot of buzzwords essentially around guard duty, but it is a very interesting piece of software. It's a very interesting offering because you can feed it a lot of info and it can essentially preemptively detect possibly malicious activity that can happen in your environment, right? So you can be relying on outside external sources of information, for example, the Open Threat Exchange, using data from AlienVault, VirusTotal, Meta platforms, and such, to essentially know that, okay, well, this IP address is doing something bad on one part of the internet. If they come around to my part of the internet, I can preemptively assume that they're probably not going to be up to any good. And if I have a reputational system, for example, for IP addresses, I can preemptively lower that threshold for that particular IP address. Or you can deploy appliances like web application firewalls. Personally, I'm not a huge fan of web application firewalls because they can provide you with a false sense of security, because they need to be quite generic to not disrupt any actual functioning software that they're fronting. But also, that means that there might be ways to bypass the web application firewalls, right? And for most of the time, that's how it goes, right? You're testing an application, it's behind a web application firewall, and you will be essentially wasting your time trying to circumvent the web application firewall to exploit a vulnerability on the application behind it. And usually it is still possible. It just takes a lot of effort to get past the web application firewall, which is fine if that's what you're using it for, as a time waster for the attacker. But from my personal experience as a pen tester, there are a lot of companies that use these devices as their only security control. And that's a very bad approach because they're not that good and they can definitely be bypassed. I can tell you that for sure. So relying on a web application firewall to remedy a known issue in your application is just not a good idea, but you do see that happening quite a lot. Okay, so finally, let's talk about AWS config. So AWS config can help you take inventory. It can also help you run compliance rules against the inventory that you have. And if there are any problems, if there are any sort of non-compliant resources that weren't there before, you can get notified through anything that SNS supports, right? So SNS is a AWS simple notification service. Essentially, they can send you an email, they can text you, they can send you a push notification, and so on. So essentially, you have your entire subscription right here. You're using various services. There's a lot going on. But because AWS config is also provided by AWS, it knows how to talk to all of those services. And the great thing about it is that you can run compliance rules, config rules against those resources very, very easily. So it can help you to continuously monitor your environment. And if something changes and it detects some additional risk, it will let you know. And it can even automatically fix things. So we actually have prepared a scenario where where we use CloudTrail, and should it get disabled, AWS config can detect that And once it detects that, it will automatically fix it through a custom Lambda function, plus it will tell us about it, right? So I will be notified. Hey, someone disabled CloudTrail, but we fixed it. But regardless, here's the details, have a look, see how it happened, investigate further. So this is the great thing about it, right? You learn about it as a person, but the machine can also automatically fix things that are very obviously broken. So the period of time during which you might be susceptible to attacks is significantly shorter than if you were just relying on human intervention. So this is essentially the scenario we'll be looking at. If a CloudTrail trail gets disabled, it's going to trigger a set of alarms, a set of notifications, and it will get fixed immediately. Well, almost immediately. Why are we talking about disabling CloudTrail? Well, it's one of the first things that attacker is likely to do. If they have access to do that, and if they do get into your account, one of the first things they would like to do is make sure they are not tracked. And if they are tracked, at least make it difficult for the forensics team to understand and find all the things that the attacker did. And disabling CloudTrail and essentially stopping the logging facility really helps in that regard. So let's now take a look at what that might look like. So I've logged into my AWS console here, and I am looking at my AWS config console. Just giving a quick refresh. It's taking a while to load. Come on, AWS. Okay, here we go. Cool. So in this scenario, we have a AWS config rule that checks whether CloudTrail is enabled on this account. Right? For simplicity's sake, we only have one rule, but obviously in a real life scenario, you would have multiple rules monitoring all sorts of aspects of your environment. We only have one here. It's called CloudTrail enabled. And literally the only thing it does is it checks whether AWS CloudTrail is enabled in this AWS account. So I'm trying to make the text bigger, but okay, here we go. Yeah. It only checks whether CloudTrail is enabled. That's literally the only thing it does. It does it periodically, every single hour. It checks whether CloudTrail is enabled. So if an attacker gets in and they take a look at the CloudTrail dashboard and they see, oh, okay, there's a CloudTrail trail here that's logging what I do. They can decide to stop logging, right? They can stop logging to this CloudTrail. And if they do that, obviously the CloudTrail turns off. And at most within 60 minutes, AWS config will learn about this problem and it can start acting on it. Now, we're not going to watch this for an hour. I will force a reevaluation here from this menu. And when I do that, it's going to take a couple of seconds, but the AWS config rule is going to reevaluate my environment, and it's going to determine that we have a non-compliant resource. Right? Something's gone wrong, and we can immediately off the bat see here non-compliant rules by non-compliant resource count. CloudTrail enabled rule is non-compliant. There's a non-compliant resource in it. So there's a problem here. So I can click on that and take a look. And I can see that there is a non-compliant resource. Clearly, something wrong is going on. The great thing about this is that you also get an email notification. Let me see. Okay, here we go. Yeah. You also get an email notification, right? So you can configure this to be notified. And essentially, AWS config is letting me know that there has been a problem detected. Compliance change notification, essentially. This message is all about changes in compliance of resources. And what's happened is a rule that used to be compliant is now non-compliant. And I get all sorts of details about what's going on, what the rule is, what is the target resource, and what's going on. So when I see this, I can go and I can start investigating what is going on. But even before I read that email, because I'm a human, so it's going to take me a minute, AWS config has already fixed this problem for us. So actually, if I just go back to this CloudTrail page, I haven't touched it since I disabled logging, so it still says CloudTrail off. But that's only because I haven't refreshed the page yet. If I refresh the page, automatically, the trail is now back on, right? So an AWS Lambda function essentially kicked in and performed a necessary intervention and re-enabled the CloudTrail. Yeah, essentially, I'm trying to go back to the dashboard. Here we go. Yeah, essentially re-enabled the CloudTrail. We can actually even see that in the history here, that a couple minutes ago, I disabled CloudTrail manually, and then AWS config stepped in, and not even a minute afterwards, the CloudTrail has been re-enabled, right? So that was quite quick reaction from AWS config there. Actually, if I reevaluate this rule in AWS config, it will now recognize that, yeah, this rule is compliant again. CloudTrail is enabled again, so it's going to take a minute. Hopefully not a minute, just a couple of seconds. Okay, yeah, so you can see that my rule regarding CloudTrail is now compliant, and I also just got an email message stating the same thing, essentially very similar format, and we have gone from non-compliant to compliant, so all is good. Problem fixed. So that's AWS config. Again, this was a very simple, very simplified demo of just checking whether AWS config is whether a CloudTrail is enabled or not. But you can make this a lot more complex. You can check that, for example, S3 buckets, there are no publicly facing S3 buckets. Right? You have a rule in your organization that you do use S3, but never publicly. And if at any point there is an S3 bucket that has been exposed to the public internet, you can set up a rule that's going to isolate that bucket for further digital forensics and determining what caused it to go public. Okay, so now let's move on to the final module of today's class, and that's going to be auditing. So I'll be showing a bunch of tools that you can use to audit cloud environments and also container images and Kubernetes clusters. So we have seen a whole bunch of attacks. So how do we detect those? How do we detect the possibility that there might be a problem in our environment? So regardless if you're on the red team or the blue team, these tools are very, very effective. Obviously for the red teamers, if they get their hands on some credentials, they can use those credentials to run those enumeration tools and try to determine possible weak points of the target environment. For the blue teamers, again, this is something you could be running periodically. If anything changes, you can be notified, and essentially it generates a decent report that you can use to determine, the overall health of your environment. The audit tools typically rely on public benchmarks. So again, a group of smart people sat down and they put together a security baseline for a particular product, in this case, a cloud environment. And typically the auditing tools simply just follow those benchmarks and they evaluate the benchmarks against the target environment. So where do you get the benchmarks from? Mainly, I don't want to say mainly, but a good resource is CIS. I think I've given them a shout out already. It's the Center for Internet Security, and they essentially publish benchmarks for all sorts of crazy software, like anything from IBM, WebSphere, MQ servers, through Microsoft Azure to Oracle DB2 mainframe databases, right? Like anything, anything you can think of, there probably is a benchmark for it on CIS. And those are typically held in a high regard by the InfoSec community. So it doesn't surprise anyone that CIA also has benchmarks for AWS, GCP, and also Azure. So if you have a pen tester coming into your place of work to do an assessment, for example, for your cloud subscription, and like give you some pointers on, or give you confirmation that your environment is in tip-top shape, or give you some pointers where you can get better, they will most likely be asking you for some credentials. And typically, the credentials you want to provide them with are those of high level access, but also in such a way that they can't change anything. That's for your own sake, making sure that nothing gets moved around, and also for the pen testers, a peace of mind, because they don't want to change anything. That would be bad for them as well. So the only thing you need to make sure is there are no write permissions assigned to those to those accounts, and there are already existing pre-configured roles that you can assign to accounts for the pen tester, right? So in AWS, the security audit policy is the exact fit that a pen tester will probably ask of you. So as you can see, the security audit job function effectively has permissions for pretty much everything, but it's all read, list, read. There's no writes, there's no creates, there's no deletes. It's literally just seeing things that exist, right? Assessing the overall situation, but never changing anything. In Microsoft Azure, it's completely the same deal. The one you want to be looking at is called the security reader, essentially allowing you to, once again, read all the configuration options, see things, see resources, but not be able to change anything. In GCP, there's a whole suite of possible roles, but again, the one most likely to be requested is the security reviewer, which is a very handy role because, once again, it has a ton of permissions, but all of those are read-only. Okay, so when it comes to automation, because automation is awesome, you can be doing things manually, obviously, but and you should, and all the pen testers that you're ever going to meet will be doing things manually. But what we like to do is to have something running in the background whilst we're doing our job, because that makes sure that if we were to miss something, there's a good chance that the automated tool would pick it up, and vice versa. So automated auditing is also something you can do on your own. You can just use some of these projects to audit your own environments. I think these tools are really good. They're open source. They only work with the access you provide them with. So as long as you only provide them with read-only access, you really don't have to worry about the tool changing anything in your environment. So you can relatively safely run these tools, and they are used by security professionals as well. So it's going to give you a pretty good baseline of all the things that could possibly be wrong in your environment. It should be said that a lot of those tools are not very smart. They're essentially checking things against a baseline, right? So they're not a human being. They don't understand the reasoning you may have had and the reasoning that stood behind the decisions that you took when you were designing your environment. So it still takes a person to read through everything, parse through everything, understand what is important and what is either a false positive or just not relevant at all. So take everything with a pinch of salt, but I think those tools are very, very interesting. So we will be looking at mainly the Scout Suite tool set. These have been, this set of tools is created by a company called NCC here in the UK. And the Scout Suite is a really useful set of tools that covers not just the big three cloud providers, but also Alibaba, AliCloud, and things like that. So yeah, it covers a wide range of topics that you can use. Okay, so in this exercise, we will be running an audit against a couple of environments here. And once we're done with that, we will move on to the next lab, in which we will essentially be looking through those one of those reports and trying to find issues with it and fixing it. So essentially what I'm going to do is I will show you how to run all of these tools and how to get access to the results. And then I will give you some time to do the same. And also I'll give you some time to try to identify a single issue that we have created on purpose. And I'll let you fix it. And after you've had some time to do that, I will then come in and demo everything for you as well. So that's the plan of attack. Sorry, scroll too far there. So let's start with enumerating AWS, GCP, and Microsoft Azure. And then I'll let you have some time to look into an issue that we're going to detect and how to fix it. So I'll switch back to my VM. I can close all of this down now. Yeah, that's fine. Okay. And I will close this file and open a terminal. That's the wrong terminal. Open this terminal. And in this terminal, I will be running Scout Suite. Firstly, I can start running, actually, let me just show you the tool. So if you just type Scout, it's going to tell you, well, I need a little bit more input. Firstly, tell me which provider would you like me to look into. So as you can see, we've got the big three, we've got Alibaba, and so on. So I can say Scout. Let's start with GCP. So I'll say GCP, and I'll feed it a service account file that I've created in the previous exercise, and hopefully you have too. So just navigate to the file you have created and feed it to Scout Suite and let it do its thing. And it should essentially start communicating with the cloud APIs and running some kind of baseline checks against all the resources that exist in the cloud environment. While that's going on, I will do the same thing for Microsoft Azure. The syntax for Azure is slightly different. You just say scout azure --CLI. And lastly, I will run this for AWS as well. So I'll say scout AWS. And this time I will say profile. I will say profile, and I will feed it the name of my AWS profile. So for me, that's user 410. For you, that's obviously going to be a different number. But once you do that, you can let it run. You may have seen my browser pop open whilst I was typing this command out. That's because Scout Suite has finished with one of those scans. So when it comes to Microsoft Azure, Scout Suite's already ran all the checks that it knows of and against all the resources that it could find. And it essentially presents me with this report. So it tells me about various services. It is unhappy about some of those. For example, when I go to storage accounts here, it gets annoyed about storage accounts in my Microsoft Azure account that have public traffic. So for example, the victim assets storage account apparently has some public access enabled, which could be dangerous. Again, might not be something you want to have, but again, this tool doesn't understand your intentions. So it could just be, a container with website assets like images and CSS files and JavaScript files, nothing sensitive in there, but the tool doesn't know that. So it will mark it regardless for your review. It's quite unhappy about app services, mainly about the fact that some of our machines have HTTP traffic enabled, which are probably not something we want to do. Ideally, we would rely on HTTPS only. So we can look through the report. It also gives you a nice rundown of what the issue is, what resources are affected, and how to remedy it. With the GCP, we can see once again, it's quite unhappy about cloud storage. You can probably guess what that's going to be. It's unhappy about public buckets and also buckets that are accessible by anyone with GCP creds. So what we can look into that issue, we can see that the victim auth bucket, the victim auth bucket is apparently misconfigured. it allows all authenticated users to read data from it, which may be not what you want to be doing. And finally, AWS has finished as well. It's got a whole range of services here. It's quite unhappy about certain things like CloudTrail, because that one's not enabled currently. It's quite unhappy about EC2 because there are some snapshots that are not encrypted, some volumes that are not encrypted, and so on and so on and so on. We've got some horrible security groups here, essentially allowing anyone to connect to the machines behind those. Yeah, it's letting us know that that's probably something we want to look into. But I'm not going to go into the AWS report too much because that's going to be the challenge for you in the Audit 2 exercise. After you've run this scan, there are multiple tools that you can use to audit cloud environments. I'm only showing you Scout Suite, but there are more than one, obviously. For example, we do show you the Prowler tool that you can use to scan again. The Prowler tool tends to take a little while. We've tried to limit it a little bit to only specific checks here. But as you can see, like immediately it starts to pick up on some problems, mainly that our student accounts do not have MFA enabled, and all sorts of different checks. It's a very interesting tool, both Scout Suite and Prowler. Scout Suite is multi-cloud. Prowler is specific to AWS, but it is worth running regardless. Like it will give you a lot of insight into what is going on, and it will generate the HTML report for you as well. So instead of watching me watch a terminal scroll, I'll put some time on the clock and I'll let you look into all of this. So what I'd like you to do is run those scans yourselves. So run those scans against AWS, GCP, and Microsoft Azure. And once that finishes, feel free to take a look at those reports, but mainly please advance to the Audit 2 lab, where you will be using the report you have just generated for AWS to try and find a problem with one of the S3 buckets, log into the console to fix the problem, and then run the audit again. Okay, so I believe the commands have been shared with you, so you can refer to those so that you don't feel lost, because I will demo this after everyone's finished. So feel free to check out those commands if you'd like to see a walkthrough, but you can also just try to do it yourself. I will demo this in due time. So let me put some time on the clock. Let's say, how many slides do we have left? We have only a handful of slides left. Okay. So let's say 20 minutes. And after 20 minutes, we will come back and we will resume the training, and I will essentially demo everything for you, and we will continue. So 20 minutes to do Audit 1 and Audit 2. Feel free to take a look, and I will see you then. In the meantime, if you have any questions, queries, would like to help us with, would like us to help you with something, just let us know on Microsoft Teams, and we will be at your service immediately. So yeah, good luck, and I will see you in 20 minutes. Okay, so that was 20 minutes for the labs. Judging by the conversations we had with some of you on Teams, I think everyone's doing pretty well. So let me quickly demo the Audit 2 lab before we move on. So let's take a look. Here we go. All right. So one of the audit reports that we ran was an S3 audit against AWS. Either you ran the big one from audit 1, or you can also run a smaller, more targeted one. But you could use the one that we ran in audit 1, and it essentially tasked us with finding a bucket that had some kind of problem with it, and that problem was a world listable bucket. So essentially a bucket that has public access enabled. So clicking on this essentially brings me the overview of what's the problem with it. And I can see that it is world listable by literally anybody on the internet. And I can see what the name of the bucket is. So I know that it is the, you just need to find yours. I think I've got a bunch of permissions allowing me to see all of your buckets too. But mainly, I can see all those buckets, and I can see that there are some problems with those. So I can remedy that. I can fix that by going into the AWS Management Console. The way to do that, if you recall, is to log in through the special link in the extra notes page. So I can copy that in to my VM, or if you're not doing this in the VM, that's fine. Log it in, paste it in, log in as user. In my case, I'm user 410. The password is what you have been using for the entire training. And once you get in, once you get in, you can navigate. Oh, actually, oops, I've been signed out. Let me quickly sign in then. Once you log in, you can use the search box to look for S3 and switch to S3. So here we go. I'm in S3, and I can see all sorts of buckets and everything going on here. I can actually see some of you have already fixed your buckets, so well done, congrats. I'm user 410, and my bucket is still maintained as public access. So I'll click on the bucket, and I need to make sure to change the permissions. So I'll go to the permissions tab right here, and you can clearly see that, yeah, this bucket is marked for public access. That might not be what we want to have here. So let's change that. So I will say edit, and just tick a box to say block all public access, and save the changes. Again, whenever you're changing things like this, AWS makes you type confirm just to understand, like, yeah, I know what I'm doing. This is fine. And that should make the bucket no longer publicly accessible. And I can verify that through running a quick audit once again. So let me run cloudhacking again, but this time only against S3. So this should take a second, and it's going to enumerate things within S3, and it's going to generate a new report for me. And hopefully that report will be free of the S3 world listable buckets. Here we go. Yeah, I'm happy to overwrite everything. I don't mind. And here we go. So I ran a targeted scan only against S3. And if I check S3 now, because I can still see everyone else's buckets. There's still a couple of buckets that have not been fixed, but my user 410 bucket is no longer here. And some of your buckets are also no longer here because some of you have already fixed your public access. Okay, so that's how you could have addressed those issues. So yeah, that was auditing S3. Again, I think those tools are very cool, and you can use them at your own organization, get a baseline reading of what is going on in your organization, and you can apply some, you can take some further steps to raise the security level and improve the security posture of your own cloud subscription. You don't need to have a security professional just yet. You can run this tool yourself and get an idea of, okay, these things are really bad. We need to work on those before we get someone in, so they can, maybe tell us about some of the more nitty-gritty details. And next up, let's take a look at container images. So an interesting concept you can use is called the golden image. In this case, that means you essentially come up with a really well-secured baseline image that you maintain in your organization, and other people, other developers might take your golden image, and when they need to, for example, create a container with a web server on it or any kind of other server helping to run a particular service, they can take your image, install the extra software they need, relax the security conditions that they require, for example, open a port through the firewall, and they can be fairly sure that the rest of the image and the way that it's configured is pretty good, right? Because someone has put this image together internally, made it super well restricted, secure by default, obnoxiously so. And the developer using this image essentially had to relax some conditions like, allow ports 80 and 443 through the firewall, install Nginx, and so on. This makes auditing really easy, right? Because I can audit the golden image, make sure that it's as secure as possible, and then all the derivatives, I can just take a look at some justification for the relaxation of some of these security conditions and understand why it has been done, and very quickly review. So auditing container images is relatively easy. There are a lot of cloud-native toolings that sometimes are just built into the cloud offerings. There are also open-source third-party tools that you can be using too. So when it comes to the cloud side of things, as I've just said, these things like image scanning essentially tend to be built into tools that and offerings that cloud providers offer you, and you're probably using already. If you are using containers in cloud, it's usually just something extra you need to enable. But you can also do things locally on your own using a suite of open source tools. You can use a big monolithic piece of software like Claire. Claire is an interesting one, but it's also a little difficult to work with. But it has really a lot of cool features. For example, it can take a container, and if it discovers that there's a problem with it, like there's an old library, it can fix it and repack the container. But again, it's quite unwieldy to use. So we will be looking at a tool called Trivy, which is a super simple tool, really, really easy to use. It doesn't have those advanced capabilities, but maybe you don't really need them. Maybe it's all about just detecting possible issues. Okay, so I'm going to breeze past Claire, and we're going to focus on Trivy. It's essentially just a single binary, simple tool. You say, Trivy, here's an image. Please scan this image. Tell me what's wrong. That's pretty much all there is to it. And by default, it's going to produce a lot of output into your, and it's going to put all of that into your terminal. But you can also implement it as a part of a CI/CD pipeline, for example. You can get results in JSON and other machine readable formats. You can even get a nice HTML report like so. So let's take a look at Trivy. So I can close all this down, and I can close this down as well. Okay, so for Trivy, we will be scanning a particularly vulnerable image that we're hosting in GCR. You probably already have GCR set up from the previous exercises, so that should be okay. You can essentially pick any image you'd like. You don't even need to use the image we provide. You can scan any image you want to, but we will be scanning this VulnHub JMeter 3.3 because I know that that one's horrible. There's a lot of wrong with that image. And as it gets older, the vulnerabilities the count keeps going up. So to scan this image, I first need to know if there are any tags on this container image. So I can use gcloud to determine that. So let's list the tags on this image. So this container image only has one tag called tag1. As you can see, it's quite old, so there's lots to be found. Before I can scan it, I need to log in to Docker. I need to authenticate my Docker prompt with gcloud. So that's what this command does. And then I can simply run trivy against this container. Now, this is going to take a while. So just so you know, I've already ran it. So I'll show you the results here. This is pretty much what it's going to look like. All right, so it's going to give you a little bit of debug output saying, talking about the things that it's doing. And then it gives you a rundown. So there's over 600 issues. There's 65, there's like 10% of them are critical. So that's pretty bad. A third of them are high risk. That's even worse probably. As you can imagine, after 5 yedire 4 years of existence, like literally any single tool on the system requires or is in dire need of an update. So like even basic tools like apt, even the package manager has a high risk issue associated with it that the installed version 148 suffers from, and it's Trivy is telling us to fix this problem by upgrading to at least 149. Even Bash has some issues with it, albeit low risk. The curl command has a lot of critical issues with it. Clearly, there's been a lot of development into curl ever since 2018. Trying to find something interesting here. There's a critical issue here. Apparently, the ping command has a critical issue with it. We should update from whatever version we have right here to this one. And yeah, you can give it a read. You can check out the report. What I quite like about Trivy is that it even understands third-party software packages and components. So, for example, here it thinks that it found some Node.js components, so npm packages effectively. So it found a Bootstrap. Bootstrap is distributed through npm, but that's just like a style sheet library, so that's not very interesting. But it can be applied to, for example, Java dependencies, so jar files. Like it understands when it finds a jar file, what it actually is. It knows what kind of library it is. So there's an Xstream library here of version 1.4.10, which has a range of critical issues associated with it. So we should update to 1.4.16 at the very least, and so on. So yeah, Trivy is awesome. It does provide a lot of value. Again, this report can be a little bit unwieldy to present to people. So you can generate a HTML report. But yeah, the terminal one works as well, depending on what you're trying to do with this. So in the interest of time, if you don't mind, let's treat this as a demo. And at the end of the class in about 17 minutes, I'm happy to provide you some more time and hang around if you need support. But for now, let's treat it as a demo and continue with the slides so that we guarantee to end on time. Hopefully you don't mind. We will revisit this in a couple of minutes. So the next topic is auditing Kubernetes. So Kubernetes can be audited in effectively 2 different ways. The first way is to look at the cluster during runtime. So that means we will be looking at the pods that are running, the runtime settings that exists within the cluster and so on. The other way of looking at it is through offline analysis. So we can be looking, for example, at the RBAC options. What kind of roles exist in the cluster? Who are they bound to? Are there any sort of dangerous roles that could possibly be used to privilege escalate and so on? So I'll be showing you a couple of tools for each of those purposes. Mainly, again, all of it boils down to running a benchmark effectively, mainly the runtime configuration checks. Right, so we're looking at pods that are deployed in the environment, what kind of security is present, do we log anything, how do we segregate things, do we use any encryption, and so on. Broadly speaking, we would recommend to use multiple tools that on paper achieve the same result, but certain tools have certain blind spots. For example, Kubebench is effectively just an implementation of the CIS benchmark. So that's pretty much all it is. But Kube Audit or KubeEye might provide extra value that Kubebench doesn't contain, and vice versa. And when it comes to auditing the roles and policies defined, we will be using tools called RBAC. And that essentially will help us visualize everything that's going on in the cluster. And we'll also be using a Python script that, if you've heard of Bloodhound in the Active Directory vault, that can help you map a path of attack. I'm going to show you a Python tool that you can use to do something similar within Kubernetes. Again, there are many tools. Just Googling for these brings you pages and pages of results. We're sharing a couple of those that we have used on assessments and have a positive experience with. So if you want to refer to this later on, you all have the slide deck. So feel free to use the slide deck to check out some of those tools. And I will now demo a couple of those for you. So I'll spin up a local cluster, which I should have done before this exercise, really, because it might take a second. Let me very quickly do that. Okay, so yeah, I'll spin up a cluster. And once that's done, I will run a couple of tools against this cluster, both for runtime analysis and also for analysis of the roles and permissions assigned to various subjects within my cluster. Again, I'm going to be treating this as a demo. However, once again, we are sharing all those commands with you. And after the training is done, you get to experiment with that as well. But in the interest of time, so that we all end on time, I'm treating this as a demo for now. Okay, so my cluster is still spinning up. As soon as that finishes, I will show you a tool called Kubebench, which effectively, as I said, runs the CIS benchmark. And it comes in many flavors, depending on what kind of flavor of Kubernetes are you using. If you're, for example, using a managed service in GCP, Azure, or AWS, there are essentially specially tailored YAML files here that can help you deploy this appliance in your cluster. That's how Kubebench works. It essentially spins up a pod, which is then used to look around itself and try to find issues with your cluster environment. Okay, I think we're almost there. Yeah, now we're configuring. Now we're making things horrible. Now we're over provisioning things. Almost there. So yeah, once that happens, I will essentially take the vanilla Kubebench job file. And essentially, this is going to spin up a new pod in my cluster. That pod is going to execute a series of commands, and it's going to generate logs, which will consist of either pass or fail checks that I can then refer to when fixing the environment. Okay, my cluster is up and running, so let's spin this up. So I'm just using kubectl apply on this vanilla job description. So nothing special. Like I'm self-hosting, right? So I'm not using those flavors that are more useful in the cloud environments. So hopefully I should have, yeah, it's already done. So if I list running pods, you'll see that one of them says completed. That's the Kubebench, and it's already done. So I can say kubectl logs kube bench, and what was the thing at the end? NLMHD. And when I do this, it's essentially going to provide me with the results of the audit. So overall, there were a lot of checks that passed. There was some checks that failed, a lot of checks that provided some kind of warning that I should probably take a look at. So I can essentially scroll through all the things that this script checked. You can see a lot of options were okay or deemed acceptable. The kubelet and the kube API server configuration was also reviewed. So, for example, the authorization mode does not contain always allowed. That was true. It was not contained within the authorization modes enabled. So that's great. It essentially does a lot of these things that I've talked about during the training. If anything fails, it will let you know, and you can fix it afterwards. Again, this is something just to read through. Having the baseline benchmark at hand is also helpful because a lot of those sections refer to paragraphs of text that is described in those PDFs. So feel free to run a tool like this against your own cluster. Again, it's a little bit intrusive in the means that you have to spin up a new pod, but the pod really runs only for a couple of seconds, and after it's done, you can just get rid of it, and it is gone forever. Right. Another tool that I'd like to show is called Kube Audit. I'm going to run Kube Audit all. As you can see, that was very quick, and it essentially looked at a bunch of definitions of namespaces, pods, services, and everything like that. I can maybe save those files in a file. Actually, let me quickly grab through the file to show you like some of the most common messages. I'll say like so. And I need to make this like so. Okay, yeah, so now we're getting the actual error messages. Let me just quickly sort and count those. Okay, so running Kube Audit on this vulnerable cluster that I had set up essentially yielded a whole bunch of errors and warnings. For example, it was unhappy about seccomp not being enabled, run as non-root was not being used. We were not really using things like read-only file systems. We even had some privileged set to true pods, so that is very worrying. Host network was set to true in some instances, so that's also pretty bad. I can actually review that really quick. Let's see who had that. So it looks like there was a daemon set. Oh, actually, that's okay. That's a system level things. That's completely fine. That's also kubeproxy. That's fine. So again, you can see a lot of those tools don't understand what's going on 100% of the time, right? So for example, it thought there was a pod that was using the host network. And normally that's bad, but it turns out that this pod was in kube system, and it's the kindnet pod. So essentially this is a system piece of functionality that makes the networking work. So that kind of needs these permissions. So this is okay. Right, so you still need a person to kind of parse through all of this and tell you, okay, yeah, well, all of these are kind of invalid because this is a system level component that obviously is going to require higher permissions than usual. But for example, the privileged true containers, that's probably going to be interesting. So there's a, let's see what kind of privileges they had. Looking through the results here, you've got a pod called everything allowed exec deployment. So yeah, the name kind of gives it away already. Lots of things are wrong with this container. The one that struck me as interesting was that it's running with privileged set to true. So that's very bad. You shouldn't be doing that. So you can be using tools like uBaudit as well to essentially give you a nice rundown of everything that's going on in your cluster. And now let's take a look at RBAC. RBAC is essentially a tool that can take a look at all the different role bindings, cluster roles, and cluster role bindings, and help you visualize everything so that you can see what's going on. On the left-hand side, we have a legend, seen this, essentially a guide on how to read all of this. We have seen this on the slide already, so I'm going to scroll past that. And immediately, sorry, I can't draw on this, I can't annotate because this is an image already. But the thing you see on the left-hand side, where it says default service account, that's a default service account. Like this is going to be assigned to pods in the default namespace, for example. And it has a cluster role called secret viewer default, allowing it to, and this is cluster wide, that's what the double stroke around it means, if you take a look at the legend. And this role actually allows you to read, change, create, delete secrets in the entire cluster. So like literally anyone in the cluster can read secrets. This is really bad. So like the first thing I see is a critical issue because this allows people to just go crazy and read all secrets in the cluster, which is pretty bad. Because if you can read secrets, you can escalate your permissions fairly easily. And you can essentially continue to review this and check out the essentially the graphs of what relates to what. For example, there's a account called John. Now, John has again cluster role binding of the cluster role called admin. And if you see this rectangle here with all the different permissions that are assigned to this cluster role, you'll see that, yeah, this can do serious damage. Like it can impersonate any service account, it can execute into any pod, create, remove, delete, everything. So John is a super user in the truest sense of the word, really can do pretty much anything. And what else do we have here? We've got anonymous to pod, essentially. So we've got cluster admin here. So cluster admin, just full asterisk, just do anything. Got a lot of wrong with this cluster. Like there are some crazy permissions on this cluster. And this tool can essentially help you visualize everything. If you're not into images and you'd like a little bit more sort of automated reconnaissance done, what you can do is you can use this RBAC audit tool, which essentially, if you feed it information about the cluster itself, so I'm going to extract the roles and the cluster roles and their bindings to their respective files, and I'll feed those files to this Python tool. It can do a little bit of automation and it can check for things that it thinks are dangerous. So it starts off with enumerating possibly risky cluster roles. And it says that, you know, secret viewer has permissions to list secrets. We have seen that. Anonymous users can create pods and even exec into running pods. So that's very bad. Like with no authentication, you are authorized to spin up pods. This is really bad. There are some questionable cluster role bindings. Essentially, there are things bound to unauthenticated users, as we have actually seen here. That's pretty bad. I think we all can feel that that's not great, giving unauthenticated users crazy permissions like, you know, spinning up pods. So you can use a Python tool like this called extensive role check.py, which can essentially give you a nice rundown of things that it deems interesting to the attacker's eyes. Okay, again, all those commands have been shared with you. I'm essentially treating this more as a demo because I've got like 5 more slides, and then I'd be happy to support you if you want to run this as a lab as well. But I'm going to finish the slides. I've got like 20 seconds left. So that was Kubernetes. When it comes to auditing the underlying operating system. Again, depends what operating system it is. If it's Linux, there's essentially a checklist of things you can be looking for. You can do this manually. If you have a security professional come in and do that manually, they will essentially put all of this in writing into a report saying, this is all the things we looked at. Here's a list of issues. You can also do some automated compliance checking through something called Linux. This is a semi-free piece of software. Ideally, they want you to pay if you're using this for enterprise purposes, but it works pretty well, even when you just get it for free. I should say, however, it works best for popular Linux distributions. If you've got something really custom, then it might struggle with finding interesting things. Same thing goes for Microsoft. Again, Microsoft provides you with tooling as well to assess the health or the security baseline of a Windows server. I'm not going to go into this too much. If you deal with Microsoft Windows servers, good luck to you. But yeah, you can be using these tools to make sure that your servers are kept in check, essentially. And the last point I'd like to make today is to make sure that even if you think you are prepared for a breach to occur, you should simulate that it actually happens, right? It's one thing to think you are prepared. It's the other thing to actually have a procedure to follow and have some experience from like a dry run to call upon when things inevitably do go wrong. Because it's usually companies that believe they're unhackable or that they are of no interest to anyone that get hacked the hardest. If there are no procedures, if no one knows what to do, and bad things start to happen, it might be a little bit too late to start learning about cybersecurity. So if you, for example, are using AWS config to monitor for dangerous things and dangerous changes to your environment, try to induce such a change, right? Try to create an S3 bucket and expose it to the public, and just sit back and watch what happens. Like, does AWS config pick up on it? Does my blue team understand what's going on? Is this going to be investigated? And so on and so on and so on. Some further reading resources if you're interested in this topic. But the closing remarks from my side would be to give a little shout out to some of my colleagues' work. They've been putting together a wiki called cloudsecwiki.com, which essentially the plan is for it to contain lots and lots of cloud-related attacks and solutions. So it's already getting quite full, but everybody likes a wiki, so that's why I'm giving it a shout out in this slide deck. And that brings us to the end of the class. Just quickly checking if there are any. Okay, cool. That brings us to the end of the class. So essentially, Microsoft Teams will go down after the class has ended, which is pretty much now. So if you'd like to talk to us, and we are very happy to keep in touch. I'm always happy to talk shop. I mean, I've been talking for 4 days, so maybe I'll stay silent for a day for a change. But you can hit us up on cloud@notsosecure.com. And we're always happy to talk about anything, cloud related or not. Post-training, we'll also try to maintain things online as much as we can. So for technical reasons, I'm being told that the AWS infrastructure will have to be taken down quite soon. But things like the EC2 snapshot exercise, where we have stolen a snapshot, right? You can still take part in that, but you will need your own account, essentially is what I'm saying. Anything that requires you to sign into your user for something account will not be accessible come 7-8 p.m. Singapore time. So just so you know, that infrastructure will go down pretty quickly, but everything else will remain online. And I mean, for example, if you want to take a look, take a closer look at something, just drop us a message and we'll see what we can do. But again, as with anything in cloud, things go through rapid development, and so we are also forced to make sure everything is still on the bleeding edge of things. So we do need to keep updating things. So I hope you understand that. So obviously the challenges do change over time, but we will try to keep at least some of them the same. So for example, the snapshot exercise will stay the same. So you will get to experiment with that. But that is pretty much it from my side. Thank you very, very much for joining us today. Not just today, for the past 4 days. It's been great. I've had some amazing conversations with some of you on Teams. So thank you for being so active. Thank you for participating in the CTFD as well. And I hope you learned something. If you'd like to tell us how we did, there's going to be a survey coming out next week. We do read all the feedback. Well, mainly my boss reads the feedback. So if you really hated me, you can tell us. But I'd appreciate it if you didn't get me fired. But yeah, if you have anything to say, feel free to say it in the survey. It would be really, really helpful for us because then we can improve the training and make sure that the future runs will be even better. So yeah, I mean, really big thank you to all of you for sticking with us for 4 days. It's been a lot of information, I'm sure, but I hope you found it interesting. I hope you learned something. I'm always happy to keep in touch after the training, so feel free to add me on LinkedIn or send me an email. My email is martin at notsosecure.com. Or you can drop us an email on training or cloud. Effectively, one of those mailboxes should be forwarded to mine as well. So yeah, feel free to drop us an email if you need any kind of support after the training. If you have any questions about the slide deck or anything, feel free to drop us an email. You can add me on LinkedIn as well. I'm always happy to chat. So yeah, that will be it, however, from our side. So thank you also very much for joining us. I hope you will have a lovely weekend. And I believe that is going to be it from me and Manish. So thank you so much and have a lovely weekend.